Okay, guys, let's look at the final example under the first series of example. Now look at the question on the board. A body projected upward from the level ground at an angle of 50 degrees with the horizontal has an initial speed of 40 meters per second. What angle with the horizontal will it strike with? Now, in our previous lesson, we derived the formula for landing velocity. So that's what we're going to do right now. We're going to be using that. Now, don't forget, this body was projected from this place like this. Now, it does two things. It gets the mass height. Don't forget, according to the question, it was projected from one level ground to another level ground. So it gets to this place, and don't forget, the first stage is mass height. Second stage is the stage whereby the body is being sent from mass height down to the, down to the ground or probably level ground or down to another place. So the body goes out like this at 50 degrees. Now it hits the ground here. When it hits the ground with a landing velocity in two dimensions. Now there's a final velocity, and this goes into component along x and along y. Now don't forget, it was said in our previous lesson that there's no change in velocity or there's no newness actually, along x, since the body is not moving on the ground. There's no acceleration on the ground. So if the initial speed is u sine theta, then the final speed also is going to be the same thing as initial speed. So that's that. But for y, this is just along x-axis. But for y-axis, it's quite different. So let's get the values of our initial velocity along x-axis and initial velocity along y-axis. Let's do that. So once we get our value for initial velocity along the y-axis and x-axis, then we can easily get our final velocities along the x-axis and also along the y-axis. So let's quickly do that. If you look at this, this is u here. You see here, this was the initial speed, 40 meters per second. 40 meters per second is 50 degrees. So along y-axis, along x-axis. Opposite of hypotenuse, don't forget, uy is u sine theta. So what's the uy? The uy is, what do we have? 40 meters per second times sine 50 degrees. While the ux is 40 meters per second times cos 50 degrees. So let's get our values. The uy is, let's quickly use our calculator to get that done. 40 times sine 50 degrees, initial speed along y-axis, that will give us 30.64. That's about 30.6, so about 31 meters per second. So along x-axis, that is 40 times cos 50 degrees. That will give us 25.7, about 26 meters per second. Now, don't forget the fact that for everything along the x-axis, all what we do along the x-axis, there is no change in acceleration. There's no acceleration. So if there's no acceleration, if there's no acceleration, there won't be any change in velocity. Velocity is going to be constant. Why? Because there's no acceleration on the x-axis. So what does it mean? It means whatever the initial speed is along the x-axis is the same as the final speed along the x-axis. So the final speed along the x-axis is the same thing as the initial speed along the x-axis. So what is going to be the final speed along the y-axis? That's what we're going to look at. Now, it was in our previous lesson, we said that if the height, if you look at the body was shot up to this place, this maximum height, the height from where it was shot from down to the mass height, you can see the mass height. Now, from the mass height back to the ground, you can see that it's the same height. So if what we have from this place to the mass height and from the mass height back to the ground, if you have the same kind of height, it means the final speed will be the same thing as the initial speed. But we can do the mathematics to confirm if that theorem is correct. So don't forget that at mass height, the final velocity is equal to 0 at maximum height. We all know that. At mass height, the final velocity is 0 meters per second. Now, there's a fact here. The body gets projected from this very portion, this very angle, up to the mass height. That's the first phase. Now, once you get to the mass height, it loses all its initial speed along the y-axis. So the next thing we have is gravity takes over. Gravity sends it back to the level ground. So let's see what's going to happen. So if at mass height is 0 meters per second, then gravity sets in. That means gravity is going to change this mass height to this final velocity, to initial velocity. Because at this place, the 0 meters per second final velocity, Then by the time gravity comes in, it starts falling back down to the level ground. So that means what was final velocity 0 meter per second now will become an initial speed along the y-axis. I mean, at mass height, final velocity is 0 meter per second. Final velocity is 0 meter per second. Then it will become initial velocity along the y-axis because gravity has set in. So what we're going to be looking for now is the new final velocity. Acceleration along the y-axis, since it's falling down now, is plus gravity plus 10 meter per second squared. Then what do we have? The time. The time it takes it to get the maximum height is going to be the same time it's going to take it to fall back to the ground, since we're talking about level ground. And don't forget, don't forget that we got our total time of flight already. Total time of flight as 6.13 seconds approximately. So the time it takes to get the max height, so it's going to take it, the time it takes to get the max height is going to take it the same time to fall back to the ground. So we have an average time, you understand, 3.06, 3.06, yes. So that's going to give us 3.06 seconds. So the time is going to take it to fall from this place back to the ground in 3.06 seconds. So quickly, let's get our final velocity. Let's see if it's going to be the same thing with the same thing as the initial velocity. So we're going to use our v equal to u plus at. We're going to use this. So final velocity is what we are prospecting for. Initial speed that used to be, that's the former final velocity, is 0 meter per second. Acceleration is positive plus 10 meter per second squared. Then the time is 3.06. So this final velocity is 0. 10 times 3.06 will give us 30.6, approximately 31 meter per second. So as you can see, it is well proven. If you're talking about the same height, it means the final velocity along the y-axis is going to be the same thing as the initial velocity along the y-axis. Just the same. But if the heights are different, it's not going to be the same thing. So you're going to be seeing questions on that, at a later period. So quickly, we have everything we need now. Our final velocity along y is 31 meter per second. So let's see the angle is going to form with the horizontal. The angle, the landing velocity will give us with the horizontal. Let's see what that is. So let's draw the components. Don't forget the final velocity along the y-axis is 31 meter per second also. The initial velocity along the y-axis is 26 meters per second. So let's do that. Along the x and y, what do we have? This is along the x and y, like this. Now along the x, what do we have along the x? Along the x, we have 26 meters per second. Along the y, we have 31 meters per second. So this is a resultant. So this is the angle theta against the horizontal. So 31 meters per second here. So we use our normal trig understanding. So opposite of our poleward, hypotenuse will give us tan of this. So that will be 31 over 26. Opposite hypotenuse adjacent. Opposite of adjacent, I beg your pardon. Tan theta. So how to get our theta? Our theta is tan inverse of 31 divided by 26. That's what our theta is. I'm going to use our calculator to do that. Our theta is the tan inverse of 31 over 26. That's 50 degrees, 50.01. So I said in our previous lesson that when it comes to angle of landing velocity, provided the height involved are the same, it's going to be the same angle, it's going to be the same landing angle against the horizontal. So it's same 50 degrees, nothing has changed, or nothing changes. So that's that for that. As simple as that.